Hello, Professor. Today I'll be talking about how I was able to design, build, and configure my net project and the site for to make sure the sites, the headquarters site and the branch site, to talk to each other in a site-to-site VPN tunnel. So first of all, coming to the design itself, I have created a topology schematic in order to make sure we understand what's going on. So the first thing we have is our firewalls. Both firewalls on our headquarters firewall and a branch firewall, which are connected via routers to each other. And from the firewall, we have a couple of switches which are divided by zones. Basically, we are implementing network segmentation, wherein we have segmented the firewall to the router as an internet zone and the staff as an inside zone, staff wherein the company, all the people who have access inside the zone will be having that zone to themselves, and all the demilitarized zone will hold all the service of that, what do you call the particular websites or whatever service they have to use. And the third final zone would come down to the guest zone who will come in and use the guest Wi-Fi or get guest network to get into the network. So this is basically mirrored on the other side of the branch network. So we were able to create the basic infrastructure and then create a site-to-site VPN, basically the IPsec VPN tunneling, so that the staff from site HQ, like the headquarters, can access servers, and the branch staff can able to access demilitarized zone at HQ. And basically, guests on the both sides are not able to do so. They cannot talk to demilitarized zone or the inside zone. They can only talk to the internet, which is basically goes out to the routers and it's out into the internet. So this is just an overview of what I've created so far. If I come down to the settings and the configuration of how I was able to uh, um, achieve this, is basically I've created interfaces. So this is my firewall one. This is which basically it's within the headquarters branch. Sorry, headquarters site. Um, Coming down to the interfaces, if you talk about the interface one, basically the Ethernet one, we have basically created a layer 3 interface, and we've assigned a static IP to it, and we've created a virtual router which basically holds a static route. It is our default route, and um, I will be talking about that once I've completed this interface. So we've created a security zone calling internet, and it's basically open to everything. Anyone can access it, anyone can go in and out. And not only that, it has a feature wherein we have the IKE gateway, the site-to-site VPN set up. Um, and basically, the link status are down because I'm doing it from remotely, as I was not able to do so uh, from the college or the school. But moving on, basically we have our interface to our Ethernet 1x2. We've assigned IP range with virtual router and creating it under the security zone of inside. And moving on to third one, which is our interface 3, which is also layer 3. Basically we added the same virtual router for all the zones, and we've created a security zone, calling it a demilitarized zone or DMZ. And the fourth final one would be the guest one. This is basically our Ethernet interfaces. This is how we ensure the data coming in and out have the perfect route to go to the particular security zone. But when it comes to how exactly people um, can use internet would be by natting. So we have created a NAT policy. Uh, I'm going to tell you once it loads, I guess. Yeah. So we created an internet access NAT policy rule. So we have created a NAT type, IPv4 NAT type, and we are basically taking all this all three zones, source zones, basically DMZ, guest, and inside, and making it as a destination as internet. So we taken all these three zones to go to this destination zone, which is internet, and the destination can be anything, like any interface. Right now, we don't have any restrictions wherein the source address can be anything and destination address can be anything, which basically translates as free for all internet, basically. And we have translation, source address translation, wherein we have dynamic IP imports and interface address, and basically all the interface would be going through the zone one, the internet zone, which is the interface one and the IP address of the interface one. Um, Pretty much by creating NAT zone, we ensure that anyone inside the network or in the HQ network can able to talk to anything outside internet. Moving on, I've also created zones, so we want to understand what's going on with zones. So how exactly can guest zone cannot talk to DMZ? So when we create zones, zones are already split apart. No one can talk to each other no matter what. So what we have to do is we have to ensure that the staff can talk to demilitarized zone because the servers exist within the demilitarized zone. So what we have created is the demilitarized zone has a user identification access network layer. Um, sorry, ACL. Basically, it is an access control list which provides a list from specific IP addresses or a specific way for only those IPs can access the zone. Right now, we've added the .8 and .56, which are basically 8 is our inside zone within HQ, and let me show you that. Yeah, right here, the IP address range is 8/29, and when it comes to the 56, right here would be our the brand site, which has the same range, 56/29, and it resides on this inside zone. So 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 the branch side, the inside zone of the branch site can people inside that, or the machines or the endpoints inside that, can able to talk to the demilitarized zone right here. Not only that, the inside zone from all the way from the brand side can also be able to talk to inside within this HQ. So this is basically mirrored on pretty much on the brand side as well. So as you see, the 8 and dot 8 and dot 56 are present within demilitarized zone, and the inside has 8, which is basically the inside zone of the HQ site. Uh, Basically, moving on, we've understand how this interconnection of internet works. We've ensured none of guests can talk to this demilitarized zone or the inside zones at all. But how can we ensure and make sure that the communication between the HQ site and the what do you call the brand site are secure? So in order to make sure these are secure, we have created IPsec tunneling. So this tunneling requires two things. Um, Basically a tunnel interface and a IKE gateway. And what we've done is we created another zone called a tunnel zone. So this one is basically has the interface, the tunnel interface. Um, and we basically, what happens is the tunnel interface will only ensure that only that the correct username and password can be able to, like, pre-shared key will be able to connect to the user and use that tunnel. So if you see right here, right now the tunnels are down. As I was saying, I'm doing it remotely. But if we look at the configuration, we have our tunnel interface and our tunnel IKE gateway, and the crypto profile is set as default for now. But if you look at not the routes, but rather the IKE gateway, we basically created the interface. So we've told the IKE gateway to create a gateway at this interface, which is basically our zone one, which is our internet, and we gave the local IP address. And the peer address would be 83.49, which is basically the internet address of the Ethernet of brand site. So as you see, the 49 is right over here. So we are authenticating this by using pre-shared key. So the same key here, right here, which is secret 5512, is shared with the other side. Only the sites know the password, and no one can actually get into that or try to crack it, because since most of the conversation is encrypted and it's going through a tunnel. Um, we can actually implement different methods, like easy methods like certificates, which is much more easier than doing a pre-shared key, and which will pretty much be useful to connect to multiple sites and create a VPN networking, what do you call. Basically, what I'm trying to say is that it's pretty easy to use certificates in order to make sure we having a secure network within these two sites. Um, so that's about it for the firewall. We'll talk about the um, basically we'll talk about the routers and how we configured the routers. I'm just going to be logging into router. Okay, so right now I'm in the uh, hit logging page, and I'll try to log into the server one. Sorry, router one. It's still not coming. Okay, I'm in. So if I want to show the running configuration to show how exactly I've built it out, would be okay. So if you see the interface 00, which basically is connected directly to the other router on the site B, has the same network. So the 33, if I pull up the schematic, so it basically says like the fast Ethernet 00 is directly connected to fast Ethernet 00 on the other router. So these are on the same plane of IP, sorry, the same subnet of dot 32/29. So 33 and 34, they can easily talk to each other. When it comes to the other side, we have 83.0 for firewall and Ethernet, which is basically on fast Ethernet 0/1. And if you look at it, so it's on dot 2. So the router has dot 2, and basically the internet which we configured previously is dot 1. So in and all, on and all, it's basically 172.16.83.1 over at the firewall, and basically 83.2 on the router side. Uh, Let me check if I can do one more thing. Yeah, so basically, in order to make sure that this router can talk to the outside, the internet, we basically created a default route. Oh, okay, just jumped on me. Let me see. Okay, so we basically created a default route which will basically tell that it has to go through the 34, which is going to be its last resort. Similarly to this router, we have configured basically cloned it on the other side. So if I go for the fourth router, okay, it's taking time. Yeah, it has to do with remote connection, I guess. Yeah, but yeah. Okay, so if I do show run, so if you look at here, so if you see right here, it's the fastest Ethernet 00 is about 83.34, which is basically correct, and 0/1 is 50, which is on the 48/29 IP range, which is directly connected to firewall, which is able to talk to each other, and similar to the first router, we have created a default route which basically tells to go talk to the other router on this IP base, which is in and all last resort. Uh, which pretty much wraps up most of the things. Unfortunately, I couldn't able to ping each other like the staff to the other staff and the server to staff to server and staff on the brand side to the other side.